today. So I wanted to use a case study, and the idea was born out of a 6-month bike trip that I did in 2009 through the Rocky Mountains from Alaska to Mexico. During that time I blogged, created a Google map which tracked real-time my position by GPS, and I wrote a book about that trip. During that time I used Google Maps to add context to what I was writing about. So an idea came to me, if you like, during that point, and I'd already decided I wanted to do a master's at UCL at that time. Could Google Maps actually be used to tell a story? As Tufte says, could we go from flat land and still land to movie land, animation, movement, time? So this was the route of my bike trip, and this was essentially what I used as the case study. So from Alaska down the Rockies to Mexico over 6 months. The presentation structure today, I'm going to give you some background, some methodology, implementation of what I produced, the successes, further work, and then time at the end for questions. And once again, Alex, as I'm sure you will, if you could G me up if I'm behind. Thank you. Okay. Technology, background, where are we at the moment? So, as we all know, WebGIS, it is growing, near geography is burgeoning, Web 2.0, the democratization of the internet, users want a richer and richer experience of the internet. Trip logging tools are also seeing growth, as is travel blogging, the use of geotagged blogs, and the personal expression of space. And as far as video is concerned, YouTube is on continuing meteoric rise in terms of its usage, and mobile video traffic is forecast for a quite stupendous growth rise until 2015. And there's also this suggestion, which comes from some work that Pickles did in 1995 and onwards since then, that maps and video in the future will become as one. So where next for maps? Putting that all in context. So in 2005, as we probably all know, GI science changed forever in many ways. Google Maps, in terms of searches, overtook GIS on search engines. The Google Maps API has doubled in use since 2010, and Google Maps itself is the most popular smartphone app in the US and in the UK. So as one of the most popular APIs on the web, a free, portable, reusable tool, could it become a storytelling tool? That was my idea. There's some interesting work that's already been done. This is a Google Earth API tool which creates an animation of a route. Share My Trail is an example of a trip blogging tool which also uses the Google Earth tour functionality, but as far as I see, the tour functionality is good but fairly rigid as far as it plays at a constant speed, which I'll come back to. Google Earth Driving Simulator API similarly. So the chronology of narrative in maps. So as far back as the Toltec era, maps have been used to tell stories. There's the canon of literate geography over the years, Hagerstrand's time geography, critical and qualitative GIS coming through the 90s and onwards, and more recently something that the researcher Richterich has identified, the principle of geomedia fiction, actually using maps to properly tell stories. And there are a couple of examples out there that I've seen where stories have actually been produced, one by Penguin, to use Google Maps and Google Earth APIs. So I wanted to see if I could take that further. But there's definite scope for improvement in the geovisualization of telling these stories. So qualitative GIS and time. Both the representation of time and of qualitative data are seen as key research areas for GI science currently, but we need tools which are more accessible in order to articulate our message. As I mentioned, there's the convergence of cartography and video. Animated maps are on the rise as a means to tell a story and as a means to express emotions, so touching a little on psychogeography here. But Google Maps API implementations are limited. And from what I could tell at the time that I did this research in 2012, there wasn't any web map that used time dynamic animation. So I'm moving at 10 miles an hour when I'm on a route. The animation moves at 10 miles an hour, I slow down and move at 5, the animation slows down. As far as I could tell, there was nothing anchoring to the real time of that journey. And also representation of linear time, so I stop, I switch my GPS device off, I switch it on later, that gap, what do we do with that? So I conducted a feasibility study, getting a bit technical here. I wanted to see if I could use a web-hosted database to take uploaded content from a user. The thinking is that it should be faster. Technology-wise, we're often told that web-hosted database is the way to go. But HTML5 is coming through, and that has some interesting features, one of which is flat file client-side storage, so basically negating the need for anything server-side, so storing it all locally, so taking a user's GPX file. I chose to use the GPX file as it's a standard GPS devices, and I wanted to use Google products as well to promote extensibility and make sure that what I was about to produce meshed correctly together. So what I did was basically created an app which took a user's GPS trace, so a GPX file of a route, allowed them to add an overlay of a geotagged blog, so blogger, but theoretically any blog can do. The same for a picture library and the same for a YouTube channel, so which is also geotagged, and that will be the photos. The illustration here is a breakdown. It's a little small at the bottom, apologies, of how a GPX file is split. It has a hierarchy of a track segment, and then within that you have the track points, which the actual satellite traces, okay, get a fix, get a fix, get a fix. Each one of those is a track point. Animation distance, I debated and discussed and analysed whether I should go for the very detailed Vincenti formula or the less detailed in terms of precision, spherical law of cosines, and happened upon a happy compromise, which was the Haversing formula, which is illustrated here. So this was a balance, as I saw it, between accuracy in terms of the speed, the distance that you're calculating, the geodetic distance over space, over the surface of the Earth, versus the time to actually calculate this in a computer application, whether it's an Vincenti formula is more accurate but very processor intensive. This is the setup that I put in place in terms of the architecture. So I hosted the data on, I hosted the programs rather on some web servers. Basically then allowed the user to input the GPS file at the client side, at the blog, and the video overlay and the picture overlay, as I said. Apologies, the orange text hasn't come through particularly well here. I used a combination of the Google Maps API to give 3D, because Google Maps API out of the box doesn't do 3D. The Maps website does, but not the API. I added in the Google Earth API. Also used the visualization API. You'll see for a moment why I use that. It's essentially for an elevation profile beneath the map view. Use something called Mood Tools, various bits of Google extensions and so forth. This is the intro screen, so user uploads a GPX file, a blog feed, a picture feed, then presses submit. I wanted to use this GPX structure, and I wanted to be able to use this with any combination of tracks, track segments, and track points. So essentially I use this triple nested for loop, which is then populating something called a jagged array, which is an associative array of sorts in JavaScript. I then worked out the animation view, decided that a point behind the actual location of the individual going along the routes was best, looking down the route, and then interpolated between the track points to get the geodetic distance between those track points, and then essentially using the time stamp in the GPS file, worked out what the speed should be, and then worked out what the timestamps were at those interpolated points. And the animation then used a combination of the Maps and the Earth APIs, so both were running concurrently within the same HTML div, and then the user can flip between them. This is essentially what I created. I will apologise now, saying I've got a web app that I've created. I'm not actually giving you a demonstration. It seems a bit lax. I have tried and tried. The security restrictions, unfortunately, on the PCs here don't allow me to upload a GPX file. From what I can tell, I've tried it on Internet Explorer, Chrome, and Firefox. So apologies there. But this is a screenshot. So we have the map view at the top. Essentially, as the user moves through the animation, which is into the landscape, as you can see, on one side, on the left, you have the blog text that comes up, and the user can then click and expand and see more of the blog if they want. And then videos and photos come up as icons on the right. So it's almost as if, you like, you've got advertising audience sort of coming towards you as you're moving down the road. The elevation profile beneath was with the visualization API, and I had various video controls that I added in and a slide beneath the profile, as you can see. Successes, I did manage to animate and dynamically link to time. As I said, at the time I did this, I thought that this was probably the first free web map app to do so, and I did also deal with the expression of non-linear time flow. Essentially, I zoomed out and used the different views, sped up the animation, and also attempted to quantify the time experience based on the animation, the user, time of the user, and the time of the technology. And the app also promotes the democratic web, and free tools can go a long way. In the future, I'd optimise the smoothing, look at computer-assisted qualitative geocoding, revise compatibility with Internet Explorer as well. There's an extension I need to add in there. Quite a few references that have come on during the presentation. If anyone wants to see more on that, please give me a shout. And that's it. Thanks very much.